Hello everybody, welcome to the video. Today we're going to be going over the notion of chords, going to be talking about some theorems that involve chords and some problems that involve this notion of chords. So just as a reminder, a chord is a straight line segment whose endpoints lie on the circle. So this is an example of a chord within this circle. And just as a reminder, the largest chord that you could draw would actually be the diameter of a circle, right? That would be the largest chord. But a chord could be any segment that is within the circle that touches the circle at 2 points. So to begin, I'd like you to take a guess and determine what you think the value of x is in these two examples. So here we have that x is this distance and x is this distance. So let me kind of highlight that in blue there. So what does your intuition tell you? What do you think that x is in this case? I mean, it seems like x is the same as 19 in this case, and x is the same as 10. That looks like they're about the same. That's using like inductive reasoning. But how do we determine for sure? We have to prove something about chords in order to do that. So let's go ahead and run through that proof. So what do we know about a chord when it is perpendicular to its radius? So here I have drawn a radius of a circle from here to the circle, and here I have a chord drawn in red, and these two segments, the radius and the chord, are perpendicular. They're at a right angle. So if I draw these two radii right here, from here the center to the two endpoints of the circle, then what I have are two triangles right here. And because these two segments that I drew are both radii of the circle, that means they're the same. This segment is the same as this segment. Of course, we have that this segment is the same as itself. That's the reflexive property. And by the hypotenuse leg triangle theorem, we know that these two triangles have to be the same, right? So because of that, that means that these two segments are the same. So this segment is the same as this segment. So that is the proof. So the theorem that you need to know is that if a chord is perpendicular to a radius, then the radius bisects the chord. In other words, it cuts the chord in half, as you can see here. So if we go back to our original problem, which was this right here, it turns out that that is the case. It is the case that here x is equal to 19 and x is equal to 10. So there's no work to show. You just have to know that when a radius is perpendicular to a chord, it basically cuts it in half. So that's how to determine what x is. Okay, everybody, let's take a look at this problem here. So here we have a circle, and there's a bunch of different segments here and stuff, but basically what you have to determine is the value of this distance x from here to here, given all of these numbers. So what are we going to do with that? So my suggestion to you when you first start these problems is to kind of determine what the radius is of the circle if you can. So here I've highlighted the two radii that are drawn, so 15.7 right here, 15.7 right here. So we know the radius of this circle is 15.7. But it's also true that this orange line is also the radius, right? And this orange line would be 8.8 plus x. So the way to do this problem is to realize that all the radii of a circle are the same. So that means the orange line is the same, is congruent to the blue line. So our equation is this. The blue line, 15.7, is equal to the orange line, which is 8.8 plus x. Okay, so we have that equation right there. And then we're going to subtract 8.8 from both sides of the equation. And then we're going to get 6.9 as our value for x. So, so that's going to be how to determine what x is. Okay, everybody, so let's go over another example here. For example 4, so here we have a circle, and we're asked to determine what this distance is from here to here. So what would that distance be? Right there is what we're asked. Well, we also know that this is x right here because the radius and the chord are perpendicular. So that means that this x has to be the same as this x, right? So now because of that, we can use the fact that this is a right triangle, and we can use Pythagorean's theorem, right? Pythagorean's theorem works for any right triangles. So the two bases squared, 8.5 plus, the two legs, not the two bases, 8.5 squared plus x squared has to be equal to the hypotenuse squared, which is 15.2. So we square the numbers, we subtract 72.25 from both sides, and take the square root and realize that the answer is about 12.6. Okay, so 12.6 is going to be this distance right here, which kind of makes sense because in a right triangle, the hypotenuse is the largest side. So if you got something larger than 15.2, that wouldn't make sense. So that's that solution right there. Okay, everyone, so as you guys can see, you have to use the theorem that we learned about chords and the Pythagorean theorem in order to solve these problems. So I'd like to go over one more example with you guys. If you take a look at this, so we're going to determine what the value of x is, and x is from this perpendicular point right here to the edge of the circle. So we're going to determine what this is, given that the whole diameter is 30.6 and this distance is 14.4. Okay, so let's go over the steps for how to do that. So once again, it's going to be really helpful for these problems to see if you can determine what the radius is. And the radius I have highlighted here in orange. It's this distance right here. So we can actually determine what that is because we know the diameter is 30.6. So we just take that diameter and we divide it by 2 in order to figure out what the radius is, right? So 30.6 divided by 2, that gives us 15.3. So we can label it on the side right there. We know the radius is 15.3, okay? So we have to determine what this distance x is, but it's going to be helpful to figure out what this distance y is, because if we do that, then we can just take the radius and subtract that distance y, and we can actually figure out what that distance is y is using the Pythagorean theorem. So remember, we know that x plus y has to be equal to the radius, right? 15.3, because if you add up these two, you get the orange line. So how do we figure out what y is? What you have to do is create a radius like this. And the reason for doing this is because we know this distance is 14.4, and we also know that this new radius that I drew, this red line, is 15.3. So we can use the Pythagorean theorem to figure out what y is, and then we'll be able to determine what x is. So the new thing here for this problem is to realize that sometimes you have to draw the radius in order to use the information given to figure out missing segments. So we use the Pythagorean theorem. That work is right here, right? 14.4 squared plus y squared has to equal 15.3 squared. We square the numbers, subtract 207.36 from both sides, take the square root, and we get 5.17. So the distance y is about 5.17. So if I wanted to figure out what x is, which is what the problem asks you to do, you plug in 5.17 in for y into the equation, and basically take the radius, 15.3, and subtract 5.17, and we get that x is approximately 10.13, so that is what the distance of x is. All right, everybody, so that's how to solve problems involving chords, so generally you have to use either the Pythagorean theorem or just the theorem that we learned about chords, that if a radius is perpendicular to a chord, what that basically means is that the radius bisects the chord. So remember that theorem as you guys do the homework today.